Hello, today we'll start with the first derivative theorem. So let us consider a graph of some function f of x which is of this shape. Over here I have marked points a, b, c, d and e. Your a and e are your end points because they exist at the end of the domain. B, c, d are the interior points as they lie in the domain. Your b and c are your local extrema. Now what does that mean? In this area surrounding b, some area surrounding b, B is the highest point as you can see from the graph. Hence you say B is your local maxima. It's not for the entire domain but in the area surrounding B. Same way, since in the area surrounding C, C is the lowest point, so C is the local minima. Over here you will have A as your global minima and D as your global maxima. Now what does the first derivative theorem state? It states that if a function f has an extrema value at some interior point P, so there's some function f of x, and at point P, so f of P, there'll be an extrema. Then the first derivative of f at point P should be 0. But this condition is valid only if your derivative exists at that point. So you'll have to check if your derivative exists so it should not be a not defined value, that's it. Then here you have the critical number or critical point. A critical point is an interior point of a domain. It lies inside the domain, that's important to note. Interior point of domain of a function f where your first derivative of f is 0 or undefined. So over here 0 or infinity, either will work. Let's take an example. Find absolute extrema of f of x equals 3x power 4 minus 4x cube in minus 1, 2. So the first step we do is we take the first derivative of the function. So we get f dash of x equals 12x cube minus 12x square. Then we have to find the critical point. Now a critical point from here we say it exists when f dash is 0 or f dash is undefined. So f dash is infinity. So we equate this to 0. Now when do we equate it to infinity? When you have some equation or value of x in the denominator. So when that equation or value becomes 0, your function becomes infinity. So those points also you'll have to check. But since here there's nothing in the denominator, it's never going to be infinity. So you only check for 0. Here we get 12x times x square minus x is 0. 12x equals 0 or x square minus x is 0. On simplifying we get x is 0 or x is 1. Therefore we can say the critical points are 0 and 1. Now the third step which you do to find your extrema is you find the values of f of x for the critical points and the endpoints as well. You have to check at the endpoints because over here in this example, your global minima exists at A, which is not an interior point, it's an endpoint. So you check your values of f of x for the critical and endpoints. So over here we know x is 0 as a critical point. We put f of 0, substitute 0 in this equation up here. Remember to take it in this equation, not f dash of x. That's a common error. Put it in f of x, you simplify, you get the value 0. Same way you do for f of 1, which is a critical point. You do for f of minus 1, which is the end point. And for f of 2, which is an end point. On simplifying, you get 0, minus 1, 7 and 16. Over here, your lowest value is minus 1. Your lowest value is minus 1 for x equals 1. Therefore, you can say the global minima, it's the lowest point in the entire function, exists at 1. In the same way, you say your global maxima, which is the highest point of the function, exists at the highest value. That is 16 is your global maxima, which exists at x equals 2. In the end here, I have written that only. Absolute minima is minus 1 for x equals 1. Absolute maxima is 16 for x equals 2. Then here you say, find the absolute extrema for g of t equals 8t minus t power 4 on minus 2, 1. This is the second example. So again, the steps remain the same. You take your first derivative, you get 8 minus 4t cube. You say, now g dash of t should be 0 for a critical point. You take g dash of t, you simplify it, you get t as cube root of 2. Now if you take cube root of 2 using a calculator, you'll find the values approximately 1.25. But our domain is from minus 2 to 1. Since 1.25 is a critical point which exists out of the domain, we do not consider it. Hence we say within the domain there are no critical points. So now we must check for our extrema at the end points. Since no critical points exist, we check at the end points. So we take g of minus 2, we get equals minus 32. Again, substitute up here in 80 minus t power 4. You get g of minus 2 is minus 32, g of 1 is 7. Hence we say the absolute minimum, because this is the lowest value, absolute minimum is minus 32 for t equals minus 2, because we're substituting t equals minus 2 here. Same way, absolute maximum is 7 for t equals 7. The next example uses a trigonometric function. Find extrema of f of x equals 2 sin x minus cos 2x in the interval 0, 2 pi. Irrespective of the function, the method, the procedure remains the same. So your first step, take a derivative. You take a derivative, your sin x becomes cos x becomes negative of sin x, and you towards the chain rule. Then the next step is find the critical points. So you equate this to 0. Again, this will never be infinity, so you equate it to 0. You simplify it, you get sin 2x. Sin 2x can be opened as 2 sin x cos x. So over here you are taking out common. Here's a step to note that you should never shift this to the other side, because otherwise you'll get 2 sin x cos x equals minus cos x over here. Your cos x will cancel. You get 2 sin x equals 0. Sin x is 0, x is 0. Doing the x is sin inverse of 0. You get sin x is 0. Doing sin inverse of 0, you get x as 0. Yes. But this is giving you only one root of x is 0. Over here, if you see, your roots are cos x is 0, sin x is minus half. Over here, you're only getting sin x as 0. So this is, first of all, is the wrong root. Secondly, you are getting only one root when you should be getting two roots. So you should always take common and never take to the other side and cancel it. So over here I say cos x is 0, 1 plus 2 sin x is 0. Over here I simplify it, I get sin x is minus half. Now cos x is 0 does not occur only at pi by 2, right? It occurs at 3 pi by 2 as well. Our domain over here is 0 to 2 pi. But so we need to consider every value where cos x is 0 between 0 to 2 pi. So you take pi by 2, 3 pi by 2, and it goes on. You have 5 pi by 2, 7 pi by 2 as well. But you don't consider those because it's greater than 2 pi. Same way as sin x equals minus half. Now this occurs when 7 pi by 6 and 11 pi by 6. Again, we know sin x is minus half at these points. Sin x is half, we know, at pi by 6. But since this is negative, sin is negative in the third and fourth quadrant. So that's why we take 7 pi by 6 and 11 pi by 6. Now for a cos x value, we can generalize it saying 2n pi plus or minus pi by 2. We can check. You put n as 0, you put n as 0, you will get pi by 2. Put n as 1, you will get 3 pi by 2 and 5 pi by 2. Same way for sin x, you take n pi plus minus 1 power n, 7 pi by 6. This is just one value, as you will see here. So again, we only consider values within the domain. On putting values in the cos x and sin x brackets, we get our answers. But over here, we take only pi by 2 and 3 pi by 2 since it lies in the domain. Same way for sin x, we get 7 pi by 6 for n is 0. For n is 1, we get minus pi by 6, which is out of the domain since your domain is 0 to 2 pi. But we know sin x is equal to minus half, even when x is equal to 11 pi by 6. We know this exists, and this is within the domain. So you have to be careful. Sometimes you can get like a trick kind of like this, where you have to check you at another value. So we get our critical points as x is pi by 2, x is 3 pi by 2, x is 7 pi by 6, x is 11 pi by 6. We check for our n points, 0 and 2 pi, we get a minus 1 and minus 1. We check for our critical points, pi by 2, 3 pi by 2, 7 pi by 6, 11 pi by 6. You get the values 3, minus 1, minus 3 by 2, minus 3 by 2. Now the lowest value over here is going to be minus 3 by 2. The highest value is 3. So the absolute maxima is 3 for x equals pi by 2. Absolute minima is minus 3 by 2 for x equals 7 pi by 6 and 11 pi by 6. You have to mention both values, that's important.